Hello everyone, it's Nick Lawson with cdc-takecharge software, and this is our second video presentation on developing a MagicCube application in Alpha software. Now the reason we're doing another one is because there are several changes to our application which, when you're looking at the code, may not be clear. So by watching it work, then when you look at the code, it'll make sense to you. Our form, when you look at it, basically looks like it did in the previous or initial video. We have our controls with our hotspots that allow you to take and rotate the faces of the cube either clockwise or counterclockwise. We have buttons that allow you to rotate the entire cube up and down, left and right. And we had these chevrons on here, but we didn't discuss them the last time because the code wasn't written for them. And what they do is they allow you to take and move the vertical and horizontal band on the cube as well as the side vertical band, clockwise or counterclockwise. That's important because as you become more proficient in solving a cube, you can eliminate steps by using those bands rather than making multiple moves with the faces to achieve the same thing. In addition to that, we've added the ability to take and rotate the cube on the front axis, either left or right, clockwise or counterclockwise. So if I want to take and move white to the top, all right, and then I want to actually solve for green, so white's going to go over here to the left, then I take and I rotate counterclockwise. There you go. Now I can take care of fix my green, get it the way I want, rotate it back, fix my white, get it the way I want it to work, rotate to blue, fix the blue. You follow me? It's when I'm working with the cube in the real world, and as I watch my granddaughter do it, that's how she does it. She moves the surface that she wants to work on to the top, and then moves the individual cells to the front so that she can then manipulate them by making moves with the side panels to the position where they need to be. Pretty cool. So now this is more real world than it was before. The other thing we've done, if you notice when I move it around, you see we have little pop-up action on the cube. What's happening here, and again it's to help the user see what the relationship is. When I move over this middle edge piece on the back, it also moves or pops up the edge piece on the bottom, because in a real cube those two edge pieces would be touching. If I do a corner, now I'm actually popping up this corner, and this corner. And if I do the center corner, now I'm doing these three. So you see how that works? That makes it much easier, again, when you're actually working with the computer to take and see where the cells are that are going to be affected each time you make a move. Final thing we'll be looking at is, I had discussed in the first video that I would probably get rid of the computer solve completely, or solving, allowing them to plug in their values and solving their own puzzle. Instead, what we did is we've set it up so that we can create moves and save them. So if I take and create some moves, if I go up, up, right, right, up, I now have a cross pattern on each of my cubes. Pretty cool. So let's say I want to save that. When I click Save, it pops up a dialog box. It allows me to key in a title, and then when I save it and close it, it appends those records to our tracking table for moves. Now I'm not actually going to save that, but I'll show you the ones that we have saved. So let's open that up. Here you go. On this form, what we have is a list box that shows unique values of each of the saved patterns that we've created. And as a means of full disclosure, I have not created all of these algorithms. I have done some, The others I got from various people that have posted on the web and made cool designs. It was up there, it's public domain, so I figured, hey, what the heck. As you take and select a value in this list, it queries the records down below. So there's an easy checkerboard, which is basically the one that I just did. That's why I didn't save it again. Now, once I have this, I can take and click Load Save Pattern, and it'll go out and load it and change the pattern on the form. So let's change it to a different one. We'll go to, uh, let's see, all 6 spots in the center. That's kind of a cool look. Okay, ready? Here we go. Just takes a second. There you go. As you can see, each cube or face has its right tiles except for the center. The centers have all been switched. Now if I want to solve that, here's my solution. I simply take and go down the list and make these moves to bring it back to the way it was. Or I still have allow the computer to solve, but it'll only solve puzzles that it created. It won't solve the real world puzzle. They have to do that on their own. But they're able to take and figure out steps, look on the web, search for answers, to take and how to take and move edge pieces and corner pieces. As they do those, they can save them. Then they can take and bring those back and run those steps so that they can solve their own puzzle step by step. I think that's a much more educational way to do it, and it ought to be more fun for the user. Okay, so what are we going to look at in this lesson? One, we're going to look at what is the code that actually moves the cell values each time you rotate a face or a band. We're also going to look at the code that I wrote for how to rotate the cube on the front axis. We will look at how to present a dialog box that allows you to take and enter values and then proceed to do something with the records in that dialog. And we'll look at a dialog box that presents a filtered list as well as a browse of records, which is queried by the choice in the filter list. That's a lot, and it'll be fun to look at it all. So if you want to see how it's done, if you want to follow along, come on over to our blog at cdc-takecharge.wordpress.com. I think you'll find it fun. Thanks a lot for stopping by, and have a great day. I hope to see you on the other side.